Now members, let us see case 2. Case 2, the first case we said, when we have roots within a given range, when that range is given, that roots are between this and this. Then case 2, here they don't give us the range. How do we know that they are between these values of x and then this? So, if the interval within which the roots lie is not specified or given, under this case, we take some values of x around or near x, i.e. both positive and negative, e.g. we can consider this range. Instead, these values are close to 0, very close to 0. Unless the sign, after taking this value now, the values from negative 3, negative 2, negative 1, and so on up to 3, now we substitute those values into the function. Then analyze the signs of f of x for which the values of x near 0. Roots of x, f of x lie between the values of x for which f of x signs change, i.e. from negative to positive or positive to negative. What do you mean? If the values you are getting of x around this interval, when you put in f of x, if there is a sign, a change of sign from positive to negative, then those values that are giving those changes in sign, then the root we are looking for lies between those two values. So let us see a good example here. Locate the roots of the following equations. They give us this. Now here, the test value I'm going to use, I'm going to locate to be around from negative 3 to 3. So if I write that interval, this is negative 3, negative 2, up to when I reach a 3. When I test for negative 3, when I put this negative 3 now in this function, this is what I get. When I put this in this function, I get this. Now, you note that there is a change in sign from negative for f of x. We note that change for f of x, for these values of x. When we put them, then we note the change for that value we got. So, after putting in negative 3 here, we got this, but after putting in this, we got this. So this one is negative, this one is positive. So there is a change in sign. When you put in all these other values, when you put in the 0, I think we saw it, we put there 0, 0, we made it a 4. Up to here, all of them are positive. Now, it means that now this equation had a root between negative, now the root is between the values of xc. This one helps us to show the sign change. Then this one locate the root where the root is going to be. So now it was changing from this to this, and the corresponding values of x that gave that change were negative 3 and negative 2. So meaning the root will be between negative 3 and negative 2. It's not with 3, it can't be 3 or negative 2. Why? Because if these were roots, then you would have been adding zeros. As simple as that. So that's why I said they are above this and below this. These ones are not inclusive. Okay, now number 2, this one. We let f of x be this function. Then we put in. Now, you see, from here up to here, no change. Negative, negative, no change. Negative, positive. So the root will exist between these two. Then, for f of x, positive, negative, there is a change. Negative, positive, there is a change. So, here this one is going to give us one root. This one root. Second root. The third root. And so that's why I'm having. So root 1 is going to be between negative 1 to 0. Because they are the values of x that gave us these changes. Then root 2 is going to be between 1 and 2. Then root 4 is going to be between 4 and 5. Why am I testing for these values? Because they are very close to 0. Now, when we come to this now, this is the next polynomial we have. You start with let f of x be this, then you test from negative 3 to 4. You can even stop at 3, it's up to you. Now, you see, after substituting these values of x in this function, these are the values we get. You change where there is a change in sign, you analyze. So this and this, there is a change in sign. So there is a root between this and this. That's what it means. From here, from now, positive, no change. Positive, negative, there is a change. It means that the root 2 is going to be between 0 and 1. Then, from this to this, not change, not change. But from here up to here, it is a change from negative 1 to 3. So mean that there is going to be a root. So root 3 is going to be from 1 up to 2. It's going to be between 1 and 2. Now, in the first video, I think you saw that when I was getting the root in the first lesson of that value, the value I got was xn equaling to 2.5. And you saw if you tested, when you substitute the other function wasn't given the 0. Why? We are going to see that in the next lesson.